Effective people focus their time and energy on things that can create miracles in their learning process. I am forever grateful to all my effective viewers for joining me for this video today. You might have heard that one habit of ultra successful people is that they read a lot. More commonly, unsuccessful people can chip away at learning and listening during their downtime. These things that crash all the productivity and effectiveness. So be proactive and realize that you be focused on for a long time effectiveness. And today's topic is on mathematical induction, and this is related to MFCS, DMS, DMGT, and intermediate 1A. And now in this video, we have to show that n cube plus 2n, which is divisible by 3 for every n belongs to a natural number. So for that, using mathematical induction, let's get started. See here, let us consider S of n. So let us consider that S of n be a statement. N cube plus 2n is divisible by 3. So first of all, according to the mathematical induction, we have to put n is equal to 1. So if you keep n is equal to 1 in the LHS part, that is n cube plus 2n. So see here, this is 1 cube plus 2 into 1. So which is equal to 1 plus 2, which is 3, and which is divisible by 3. Therefore, n cube plus 2n is divisible by 3, and therefore S of 1 is true. So for n is equal to 1, the given statement is true. So according to the mathematical induction, we have to check with n is equal to 1 first. And later in the step 2, we have to assume that S of k is true. So which means that we have to put n is equal to k in the given statement, that is n cube plus 2n, which is divisible by 3. See here, if you keep n is equal to k here, this will be k cube plus 2k, which is divisible by 3. So here, so this is very important that k cube plus 2k is divisible by 3. And if it is divisible by 3, so here the quotient is m. So let us say that the quotient is m. Therefore, n cube plus 2n is equal to 3m, and n cube value is equal to 3m minus 2n. So name it as equation 1. And now in step 3, so we have to show that S of k plus 1 is true. For that, see here, S of k plus 1 is true. So now we have to prove it. So what is S of n? N cube plus 2n is divisible by 3 in this. If you keep n is equal to k plus 1, see, in place of n, k plus 1, in place of n, k plus 1. So consider the LHS part. So this is the LHS part, and here n cube plus 2n. So in place of n, have substituted k plus 1. See here, what is a plus b whole cube? This is a cube plus 3a square plus 3ab square plus b cube. So if you substitute in the formula, that is a cube plus 3 into a square b plus 3 into a b square plus a cube. So this is 2k plus 2. See, I am bringing these two terms at one side. So that is k cube plus 2k. So this is k cube plus 2k, and the remaining 3k square plus 3k plus 1 plus 2, this is 3. So clearly, so this is the thing which we got after rejoining the terms. Next one, so this is the case. So what is our assumption here? Our assumption here from the given statement here is, so after putting n is equal to k here in the statement, this is k cube plus 2k is divisible by 3. So according to our assumption, that is k cube plus 2k is divisible by 3, and here k cube plus 2k, which is divisible by 3, and here these are all the multiples of 3. If I take 3 common, so this is 3 into something which is an integer which is also divisible by 3. So this is divisible by 3 and this is divisible by 3, and therefore the addition is also divisible by 3. See here, the same thing I have written here. So according to our assumption, this is divisible by 3, and after taking 3 as common, this is 3 into an integer which is divisible by 3, and therefore the first term is divisible by 3 and the second term is divisible by 3, and therefore this addition is also divisible by 3, and therefore S of k plus 1 is true. So it is true for n is equal to 1, 2, 3 and k plus 1. Therefore it is true for any natural number, and hence by principle of mathematical induction, we say that S of n is true for n belongs to a natural number. Therefore n cube plus 3n is divisible by 3, and this is how we have to show that. So this is also so simple, most important, and please let me explain you once again. So we have to show that n cube plus 2n is divisible by 3 according to the mathematical induction. First we have to put n is equal to 1 in the LHS part. If I keep n n is equal to 1, so this is clearly divisible by 3, and therefore s of 1 is true. And next one is our assumption that s of k is true. So in this statement, if you keep n is equal to k, see here, this will be k cube plus 2k is divisible by 3. Now we have to show that s of k plus 1 is true. So for that, if you keep n is equal to k plus 1 in the LHS part, see here, this is the calculation, and I have taken k cube plus 2k. So this is k cube plus 2k plus 3k square plus 3k plus 3. According to our assumption that this first part is divisible by 3, and if you take 3 common from this, so 3 into some integer which is a multiple of 3, therefore it is divisible by 3. Therefore if two terms are divisible by 3, then the addition is also divisible by 3. Therefore it is true for s of k plus 1. Therefore, if it is true for 1, 2, 3, k plus 1 and so on, it is true for every natural number, and therefore the given statement is divisible by 3. Thank you so much for watching. If you really like this video, you know what to do. Please raise your thumb, subscribe to this channel, stay connected, and have a look at my next video too. My next topic is going to be on sets and relations, which is very, very important for discrete mathematics. So I welcome your subscription, and thank you so much for staying till the end.